Well, good morning, everybody. Welcome to Conversations on Critical Operations. Today we're talking to David Trombly. He's an engineering supervisor at University of California at Davis. Good morning, David.
Good morning, Nick. Thanks for having me.
Great. And I'm Nick D'Orazio. I'm from OSI Soft. And as we go through today, please use the chat in YouTube to ask questions if you want. So, David, can you start by just telling us a little bit about UC Davis?
Sure. UC Davis is part of the University of California system. It's a large land-grant university. It's actually the largest UC by land. Some notables, we have a well-known vet school, top vet school and ag program. And we also have sort of a lot of other programs. We have a good engineering program and some professional schools. We have a medical school across the causeway in Sacramento, as well as a business school and a law school. And we also, relevant to this discussion, we have sort of a city-scale utility system that my department maintains.
All right, and we'll talk more about that engineering department and some of the things that you're doing with the real-time data with that engineering department. What do you do at UC Davis?
Yeah, so I'm an engineer in the utilities department. I supervise a team of engineers and analysts, and basically we're responsible for helping the campus buy electricity and gas and manage those contracts, as well as charge folks who use our utilities. And then we also manage a lot of meter and data work on campus, and then we're trying to help our utility systems run optimally and comply with environmental regulations, and also help plan for future capacity of our utility systems.
Okay, great. And one of the things you presented at Pi World Online, and I really encourage everybody to go out and watch all the Pi World Online, David's in particular. And one of the things that you said during that presentation, and this, this interview, we're not going to duplicate much of what you said there, but I want to dig down into some of the details. You just mentioned in passing that one of your big goals was to have, in your use of real-time data, is to have a single kind of infrastructure for that real-time data. Can you describe what you were talking about?
Sure, yeah. So just to refresh, I think the example I gave there was related to our central heating and cooling plant, where previously we've had data in our plant SCADA system and then other data in our building SCADA system, and we were able to bring those all into Pi, and then that enables interesting screens to look at situations where those two systems basically are interdependent and break down silos. That's really what I'm talking about. We have data in a lot of different places on campus, and increasingly, as kind of things become smarter, there's more and more data, and so our vision for a
Yeah,
single data infrastructure is to have all that data in Pi.
right. And we'll talk about those, and also, I mean, there were a couple of other things that popped up in your presentation, like your use of Wi-Fi metrics. I'm
Yeah.
dying to figure out how you got all that into the, into this one system. Because see, this is just it's a cliche, these silos of data, and we always talk about it as though it's like a fait accompli that we now have a single infrastructure for all this kind of stuff.
Mhm.
You dig into the details, and it gets to be fascinating of all the different interfaces that are required, all the different ways people are grabbing that data. So we'll see if we can get into that as we go along.
Yeah, that sounds great.
Yeah. And one of the examples you described, there was you described a chilled water and a chilled water system that had traditionally, I guess, was it your chilled water? Well, is that what you were just talking about, the chilled water and the
Yes.
heating system that had never talked about? So what were some of the difficulties that were presented by that?
Well, so
I
this
mean,
is,
what couldn't you do that you'd like to be able to, or you're able to do now, I guess?
yeah, so the big point of kind of connection with respect to energy savings is especially that, the plant, the central heating and cooling plant, has these large electric chillers that are making cold water. And then that cold water is distributed around campus and used by the buildings, and then returned to the chillers. So, and then how the buildings operate and use that chilled water in their building heating and ventilation systems and air conditioning systems really impacts the efficiency of the chillers. And specifically, this quantity delta T, which is basically the difference in temperature between the chilled water supplied by the chiller and what returns to the chiller is very impactful on chiller efficiency. And so if buildings are not kind of using the cooling they're getting and returning back a much lower much higher temperature back to the chiller, then that impacts chiller efficiency. So essentially, exposing the data from both systems made us able to to see which buildings were impacting chiller efficiency, and then ultimately see the results on chiller efficiency.
We've got some slides. We're looking at the delta T screen. Now
Yeah.
you were saying that this type of comparison was just something you weren't able to do before in the past.
Yeah, that's correct. Just having a single view of all the buildings, delta T and flow, and then how the plant is behaving as a result was not something we were able to see before. So the power really is for the plant. If the chiller is not running efficiently, the plant can then identify why. Whereas previously it was a total black box. And then that then feeds into you know operational collaboration, because all of a sudden there's enough information for folks to actually substantively collaborate. Whereas before, it could just be like, hey, our chillers aren't running efficiently. What are you guys doing? And they might say like, we have no idea, or we have to drill in and look at the different buildings. But now it's kind of all there in a single view. Um, and then similarly, a building operator could look at a building and see a building that's high flow, low delta T, which is kind of a energy problem, and then either fix the operations or identify a retrofit that needs to be done, or whatever it is.
Okay, right. What were the interfaces that you needed to use to get that two sets of information together? Was that both from the same control system, or were it different control systems?
So the plant control system is a Wonderware system. So we're currently using the RDBMS interface for that. We do not that particular Wonderware control system, but a different Wonderware control system. We've actually collaborated extensively with OSIsoft to use the new Wonderware connector, the connector for Wonderware Historian. So eventually that's for our water and gas SCADA system. Eventually we'll roll that over and use it for our central heating and cooling plant SCADA system. So we really like the connectors, and the fact that the new tags now are created automatically, and there's quite a bit of benefit there. And let's see, the building control systems are largely Siemens systems. So we've used different methods to get those into Pi, but largely we've used RDBMS and OPC at this time.
Okay.
Yeah.
You actually make use of Wi-Fi Wi-Fi information to help you figure out what occupancy is like currently in the rooms.
Yes.
Where in the world did you get Wi-Fi data, and how did you bring it into the Pi system?
Yeah, so the campus has a way of accessing um, the current, every 15-minute count for all the different Wi-Fi hotspots on campus, which are generally named by building and fairly discernible what they mean. So that was available, and we were able to essentially pull that from a website, and we're using the UFL connector to essentially do a HTTP get of that. I don't know, maybe I didn't quite use quite the right term, but we're getting that from the website using the UFL connector, and then that sort of parses it and goes into Pi.
Okay, yeah, the UFL mean the Universal File Loader.
Yeah.
Basically, okay.
Yeah.
Right, yeah. For getting data from a variety of things, and in this case, you're using it to parse out that web data.
Yeah, and so the new connector has been especially valuable to us because the UFL interface, you seemed like you had to mostly kind of put the data in a place, but the connector has the ability, you can do REST posts or get kind of gets using REST. So there's a lot more that can do, and then there's also just the fact that again things are kind of more created automatically as new data tags come in and things like that.
So tell people what we're looking at here.
Yeah, so the ultimate end game here is to schedule buildings um, so that they're off when no one's there. Now, not all buildings are fair game for that because a lot of our buildings are labs, but there's some where folks aren't around on the weekends or on holidays, and so we have a team that's trying to optimize our building energy use, and this was something they wanted to do, but it's a difficult problem, and so one of the things they did first was kind of looked at the schedule, and they've automated ways to basically um, kind of get a good look at the schedule for the courses and other events, and then turn off buildings that aren't, or rooms that are, or zones that are not being used.
Right,
Um,
and that's something people have done for decades, I imagine, right?
yeah, although um, you know, it's not a given. I think there's a real, it's difficult to take the scheduling systems and and integrate them with a evergreen method of dealing with the HVAC scheduling. So there's, I think, the opportunity, even if you were to, at one given point, optimize it perfectly, the problem is that you have people constantly changing the HVAC scheduling, and you have people, and
Right.
the schedule is constantly changing. So there's some automation needed to really make that good. But so then,
Okay.
having done that, that was a uh, good starting point. But but we wanted to go farther, and so what we're actually doing is we're sort of testing and verifying places where I think probably the worst case scenario is there's an event that we missed and someone's there um, and the HVAC is not on. And then another a second problematic scenario is the HVAC is on and no one's there. So those are kind of the two inverse scenarios. So on the top, we have that exact scenario. So the purple is the graph of the occupancy based on the Wi-Fi count. This is just like number of connected devices. And then you see the HVAC, that's the little kind of square red
Right.
boxes. So this is 16 days. So you can see basically every day is on at this building. But what you can see is that there's periods where there's virtually no one there. Um, so once we had this data, we could turn things down and then or off, and then essentially, so that's the good. So you see um, in a later period, this is the first one is in June of 2019. The second one is in December of 2019. We're basically able to turn things off, and we have a good sense for verifying that yes, in fact, no one is there. There's no one on Wi-Fi. And so you see that the gold is kind of intermittent now, and those correlate with the blue, which is the Wi-Fi occupancy. And then another thing we've done is we've actually used Pi notifications so that if there's times where the Wi-Fi occupancy goes up and the HVAC is off, because it's now all in Pi, this is a use case where we're essentially um, the value here is the HVAC data combined with the Wi-Fi data, and then if the HVAC is off and the Wi-Fi occupancy is up, then there's a notification and someone can go in and turn things on, maybe
Hmm.
before complaints happen and that sort of stuff. So
Very cool.
yeah,
One of the things you mentioned in your presentation was that you are doing you're working with some outside vendors, and practically part of your selection criteria nowadays is are you able to look at our real-time data? Do you have the wherewithal? Do you know the tool set, et cetera, et cetera? Tell me a little bit about that.
yeah. So I mean, we acknowledge that there are a lot of ways to look at real-time data. So we didn't want to make Pi or knowledge of Pi or use of Pi a single issue thing with respect to selecting a consultant, but we did recently. We're doing this big chilled water system optimization, which I've hinted at a little bit already, and we did decide to include knowledge of Pi as a requirement in that RFP and the subsequent interviews. Um, and the thought there was that our life and our project will be a lot better and easier if consultant also has a knowledge of Pi. So we ended up getting a consultant, Smith Engineering, that kind of has a similar level of use of Pi, pretty pervasive, and it kind of turned out that there were a lot of other things with them that aligned well, but the use of Pi, I think, in some ways, I feel like if folks use Pi, that's somewhat likely that other values will also align. So I don't think it's an accident that we aligned in a whole bunch of different areas. But
Right.
right now we're basically sharing our Pi data with them, and they're
Okay.
using that to do their project.
So what mechanism? You know, we got a bunch of different ways of sharing data. What did you all choose to do?
Yeah. So right now we're using Pi to Pi. We considered a few things. We considered like the Pi Web API and Cloud Connect, but right now we've kind of for historical reasons, I think they're still using Pi to Pi, and that's how we are doing it now. Um,
Okay.
there's going to be some
Cool.
other sharing though, kind of back toward us. They're building Pi Vision screens on their side with our data, and then eventually we're gonna share those back to us. So I think that'll be a cool process as well.
Okay. Cool.
Yeah.
When you came on board, there was already a Pi been or the your use of real-time data had been around for quite a while, from back to
Yeah.
2006 or 8 or something like that, right? So what was it like that you stepped into? Can you describe your process and kind of
Sure.
what you picked up, what you started doing?
Yeah, and let me just say one more thing I think it's worth mentioning in terms of this one version, kind of one system of record. For different kinds of use cases, there's lots of different systems of record, like financial. Pi is not our financial system, but one thing that's valuable about Pi is really, especially with some of the later tools like the Pi Web API, the ability to integrate with other systems well and get data in and data out is really valuable because there are going to be other systems of record, but as long as those systems can talk to each other, there's a lot of value. Um, we started using the Pi system in about 2006, and I came to UC Davis in 2014. Um, there was a person there who was a couple of folks there who were working on Pi, but they had either moved on to other jobs outside or inside the organization. So the Pi system was, I'd say, in slight disrepair. So I did a lot of work, maybe 75 to 90% of my first 1 or 2 years working at UC Davis was working on Pi and getting the Pi system back kind of where it needed to be. Um, so that included kind of cleanup and merging systems, as well as installing new software that had come along. Probably the biggest one that came along that we didn't have yet was a good implementation of AF as well as a good implementation of Pi Vision. But early what I did inherit quite a bit of initial work. So we had some good operator screens. We had a pretty self-sustaining energy dashboard that was created maybe in the late 2010s or late 20s or early 2010s. Um, and
Very early, right? You were
very
thinking it's
early.
probably one of the earliest facilities dashboards that had ever been created, I
That's my
guess.
opinion. And the amazing thing is just it was using Pi SDK and it was written with Visual Basic and it was just humming away like no one had really touched it, but it was working well. And then we also had quite a bit of building meter tags and uh, central heating and cooling plant tags the data was collecting and things were going well. There was, it's interesting as you neglect a system over time, either data points or data sources may start to kind of be lost. So there had been a migration done that kind of left some data behind, in other words, it was not a um, Pi aware migration, such that the Pi data stopped coming in when the migration was done. So I
Right.
had to fix that, and there were also a lot of meters for various reasons that were flatlined. So this is data that's coming into Pi, but it's either there were latency issues in the metering side or um, various problems where just no one had been looking at the data long enough to or frequently enough to notice these problems. So I would say like there were a lot of kind of structural systemic things I did early on, but again, including installing new software. But then as I started to get into the data, there was quite a bit of kind of more tag by tag look. And the interesting thing is that I did that maybe from 2014 to 2016, and then I kind of became a supervisor in the 2016 timeframe, and there were folks who came after me who I was supervising who probably could say the same, really almost the same thing. Like they got a better system from me, but they had their own generation of improving stuff that I hadn't gotten to. And then we honestly had another group that's here now, maybe starting in 2018 or so, who found a whole nother, kind of went to a whole nother depth. Ultimately the goal being to ensure quality data and expand the data we have and implement good business processes so that we have good data um, going forward, and we know if it goes bad. And all that is kind of built on the presupposition that we want the data. There's a lot of business value in having the data and having it be
Okay.
good.
Yeah. I mean, and well, I guess we don't want to get into a lot of the weeds of how you straightened out all those, all those IO timeouts
Yeah,
and tags that weren't aligned anymore. And
yeah.
do we still have tool sets? We used to have at some point we were trying to share tool sets to allow people to make that easier. Um, did we offer any help with that?
Um, I don't
Yeah,
remember
I
right
should
now.
look that up. My
Yeah.
information's 10 years old.
No, that's
But
okay. Certainly I used PyTools to look at the data. Early on, we implemented Pi notifications to send emails when the data was bad for a certain period of time. We've kind of now that notifications are and event frames are kind of more merged, we've kind of moved to event frames in some cases. In some cases, we actually have Python scripts now that we're using with the web API. So
okay,
what I'm saying there is that as that early on we implemented ways of triggering if the data was bad, so that at least we knew. Because an early on sinking feeling I had was to say someone asked for the data and I say, yeah, we have that, and then I look at it, oh, it's been stale for 9 months, you know.
right. And you were telling me that there are you actually have put some workflow processes in place to try to ensure that the data does, that you have some kind of quality assurance on the data.
Yeah,
That you're looking at data quality all the time.
yeah, we've done
Can you describe a little of that?
Sure, we've done a ton of work on this. I mentioned notifications and event frames and Python scripts, but we basically have I have 6 people, including myself, who are involved in this, and 2 people per month are appointed to sort of review. We have these. One of our data analysts creates graphs and showing the data and kind of doing tests to see if things are bad or stale. And then we have a couple folks Tuesday, Thursdays that review those, and then we have systems to kind of create work requests to let the meter team know who's out in the field, know and prioritize work, kind of as also as a function of what the meter's used for. Um, so we're doing that, and we also have, for some of our really critical meters, we have notifications that come if the data's been bad for 10 minutes. That has been a place where we've had to deal with kind of nuisance stuff and too many, and had to tune things and tune the true time, especially. Um, so then another component of that is so that's kind of more on the data side, but we've also been doing really extensive work on the meter side to implement a meter verification program. Um, so basically, um, the, the the two big components of that are, one, to ensure that new meters that are installed. Well, I'm going to actually say 3 things. One is we had to inventory our meters. We didn't even know what meters we had and and what they did always, and which meters should be summed or subtracted to get the building energy usage or water usage. And then we then have had to implement processes with our design and construction folks to basically, if a new meter's installed, how do you ensure that the meter is configured properly and is reading data correctly? And then we've kind of operationalized that to work with our warranty period, so that if there's a problem after a certain period of months, we know about it and can go back to the contractor who built the building. And then so that's new meters and new buildings. And the third component is for existing meters and buildings. We're basically kind of doing a paint the Golden Gate Bridge type style project where we're going through all of those and verifying those. That's my team essentially working with our meter instrumentation and controls folks. So
Okay,
yeah,
cool. That's very cool. Well, one of the things that, well, I wanted to ask you, what's your results have been, it seems like extraordinarily good. I mean, I'm showing a trend right now of, I think this is the energy savings over the last uh, 13 years.
yeah, it's one of our
Just
favorites there.
yeah, just incredible. And the you've also had likewise you've met these you haven't met your carbon neutrality initiative goals yet, but you have met your water goals,
Yeah,
your
that's right.
water use goals,
That's
which
right.
is really kind of astounding.
Yeah.
Describe a little bit about the process and what kind of results you've gotten.
Yeah. You know, I'm one person, but as you can imagine, I think the number is 46% reduction in energy use intensity. That takes a lot of support from a lot of people, kind of on the from the senior management side all the way down to those who are implementing the project. So um, I I would be remiss if I didn't just mention that there's a lot of folks who are who have worked on this and kind of had to buy into our initiatives. And then there's also just been good incentive programs with through the PG&E and working with the Office of the President to incentivize energy savings projects. Kind of painting in broad strokes, I'd say early on, we were mostly focusing on really big known opportunities, especially at our plant. One example is installing a condensing economizer at our central heating and cooling plant to basically reuse energy that was leaving out of the stack of our boilers. Um, and then over time, there's been a pretty big phase where we were retrofitting buildings. So that's kind of another phase that's happened, big retrofits. And then now we're kind of moving more into a phase of optimization and tuning building operations, not so much large retrofits, but just using data to maintain savings we've already achieved, as well as to find opportunities for further savings.
Right, and that's the optimization is where the knowledge of real-time data is, really is tremendously valuable.
Yeah,
But there were a number of instances in which the real-time data was really a part of your process of doing some of these big retrofits
yeah,
and even some of the design. Is there anything that comes to mind with that?
yeah. One of them is a project we're just breaking ground on now. Interestingly, the fact that we have suspended operations on campus has enabled us, I think, to make more progress than we would have. Um, so this is a steam to hot water conversion project. So this is our next big. This is actually less of an optimization project and another one of the kind of bigger retrofits that we're talking about. This is a conversion of our current steam system, which has a lot of losses and is a natural gas system, into a hot water system, which will ultimately have way fewer losses and have heat recovery between our cooling and heating systems. And it will be largely electric, potentially fully electric. Um, so we used Pi data a lot, especially for that project, for the design. So I believe the student interns and other analysts were using essentially Pi data on our existing demands to do design for that project and to work with the design consultant. So this is something that's expanding at UC Davis as we collect more data. Just the fact that you can, without real-time data on a system, you can use engineering principles to design a new system or to do a retrofit. But if you have real-time data, you have a much better idea of how to size your system, how to size the pipes, what kind of demands are needed, peak demands, as well as you know, daily or annual
Okay,
requirements.
cool. So what you've talked a lot about the importance of getting data into the hands of experts. And can you name some of the different experts? There's a whole variety of people that are using this real-time data.
Yeah,
Can you describe some of the different groups?
Sure. Um, so there's researchers. So I don't know if I can think of a professor right at this moment who's pulling Pi data, but certainly their grad students are. So we have active projects that are collaborations with researchers to use our campus as a living lab. Um, Sometimes we'll pull the data for them, but um, we have one project that's I think a pretty special project in that there's kind of two kinds of research projects. One is one where we're pulling the data, but it's more just for a researcher to kind of use our system as a test. But we have a project right now, it's our chilled water optimization project, where we're really actually collaborating with researchers in the Department of Chemical Engineering to do an actual optimization project. And we're like, they're like part of the project team, and they're using Pi for that project. So that's the researchers. Students is another one. We have a lot of places where we're sharing data with students for classes, and we have a lot of interns who are either who are doing work on our various parts of our systems that are using data either for like lead verification or helping pull data to see how buildings are doing or helping with reporting, energy reporting. Um,
Right. Hey, let me bring up. There's a display. I'm showing right now your UC Davis energy map. I think it's called the Seed
yes,
project.
yes,
Yeah, and this I found absolutely fascinating. You've been exposing this data to the public, to
yeah,
your well, just describe what we're taking a look at here, and I'll just kind of use some of the user interface
yeah.
as we're going through this.
Are you looking at the bubble one or the graph one?
I'm looking at the bubble one.
Yeah, okay, so
The,
that's the front page. Yeah, so I mentioned researchers and students. This is the public, really. I mean, I would say really this is geared toward our campus community and the folks who are in the buildings. We have the group is called it's called the Campus Energy Education Dashboard. Um,
Mhm.
so the goal here is primarily to give energy information to the occupants at the buildings, but also this is a public website that anyone can view and see how UC Davis is doing. The bubbles are displaying the energy use intensity, which is like energy normalized by square footage for all our buildings on campus. And then we also are,
Mhm.
you can drill into a building and see um, monthly usage and compare buildings to other buildings and see real-time demand data.
Yeah, one of the things I'm doing right now is I love this slider, how you can immediately see what the resource hogs are, the energy hogs,
Yeah,
and
absolutely.
then you can just drill down into that and actually look at the building data
Yeah,
for this is what is it 24 hours, and then we'll go back and look at 7 days.
yeah,
So it's just absolutely
yeah.
fascinating. And as you've done this, you've actually found some people. I mean, people who've actually made changes based on some of the things they perceive.
Yeah. I mean,
Um,
I don't know if I can think of an exact example of that. It is interesting so that's kind of us giving them feedback. And I mentioned in my talk that there's also they're giving they're giving us feedback. So um, about their
and
comfort, and so then that's results in a lot of changes that we make.
now, and that was done with the, or was that the web API that you used for doing that?
Yes, this dashboard is built with the web API.
You've done a lot of things with the web API.
We really like the web API.
Okay.
Yeah. You know,
Can you just? I'm
I'd
sorry.
like
Go
to
ahead.
just mention real quick. I just was thinking about this dashboard. You know, UC Davis has been really amazing with funding and supporting these kinds of projects. Even just providing, we have a project manager, Kiernan, who's a web developer or a project manager, and we have web developers that are designing these things in-house. And really at the chancellor level, that team was funded. And then really also on the energy saving side of things, they've supported kind of a seed funding for a green revolving fund so that we can essentially um, sort of claim the savings we get and then reinvest them in our own team. So I think that's an important component, just worth mentioning. But go ahead. What were you going to say?
No, that's actually something I wanted to ask you about. It's a nice model because you're saying the seed funding was just kind of to proof of concept, and then based on your savings, you're doing further work based on the savings you've been able to demonstrate.
Yeah. So I think the best way to picture it is they basically funded a team and let them dig a hole, a financial hole, and then we're tracking the savings based on real-time data, measurement and verification of savings using real-time meter data, and then essentially transferring money to sort of little by little dig out of the hole. And then eventually the team is going to be a self-supporting team once they've dug out of the hole and they're basically have achieved savings to pay for their own salaries and whatever other costs they have.
Cool. Oh. Now, are you familiar enough with the web API and what work they did to? I mean, can you describe like what platform they're using to do the development and what kind of tool sets they're using to develop these cool things? I mean, there was some neat geosynchronous kind of stuff that you were seeing there.
Yeah. I'm a little less familiar with that. I know that that a lot of our websites were developed in Node.js or React.js. I think it's called React. So that's kind of a front end thing.
Okay.
And then
Well,
those are doing calls
we can
back into
skip
the
all the details.
yeah, those are doing
Okay.
calls back into the web API.
Okay.
Yeah.
Cool. Cool. But they've been able to get a lot of good work done. It's a robust API. I mean, we have a variety of ways of accessing data, web API being one of them.
Yeah.
So, but the important thing is that this is a real-time data application that actually you've seen this over time. You've seen when you've been able to expose people to more information, all of a sudden they change some of the behavior. And we've got a slide that shows a great example of that. Let me see if I can bring this up here. Yeah, I'm showing right now a slide, this advanced operator feedback slash optimization,
Yeah.
which is showing the rate. You were just exposing to people what the current rate was
Yeah.
and what their activity was in chilled water. Describe that example.
Yeah, so a little background here. I've mentioned we have these large electric chillers that they use electricity to make chilled water. They're each about, we have 8 of them, and they use each about a megawatt of electricity. So just to give perspective, our campus in the day is using about 40 megawatts, and in the night about 20. So these 8 chillers, that's like, quite a bit, a significantly large percentage of our total electricity. In other words, you can see on the real-time data for the campus when these chillers go on and off. um, and then we also have a large tank. It's a 5 million gallon tank that allows us to store the cold water as desired, basically. So, up to the capacity of the tank. Um, so,
Right. So
um,
there's
and then another thing is we've done quite a bit of work I would call this kind of an aha moment. We've become aware, we had thought for a long time that our electricity rate was more flat, like it was probably varied monthly, but didn't have a significant hourly component. But what we've learned through quite a bit of digging, along with it's kind of as part of a grad student master's thesis project, um, we've learned and worked with our electricity supplier to find out that our we actually have hourly varying electricity pricing. Um, so as you can imagine, then we can basically flexibly dispatch our chillers when we want, using the chillers to either feed the tank or to feed campus when the power is cheap, and then using the tank to provide the cooling when the power is expensive. Um, so we created this screen to essentially put in front of the operators the electricity pricing as well as um, the their chilled water use actually it's the electricity used by the chillers in kilowatt hours. Sorry, in
right. So
kilowatts.
the use is the orange line. The green line on the top is the current rate.
Yes, and also the projected rate for looks like about
Oh, okay.
24 hours. And then another thing
Okay.
we calculated for them, this is a PiVision screen, was that says that the TS tank by itself could satisfy campus for the next 17 hours. So this is meant to help the operators know if they look ahead and see a price spike coming up, uh, what do they need to do? If that number was 1 hour, then that means they don't have enough storage to kind of get quote unquote get through the price spike. But if it's 17 hours, then they know they can run from the tank for a long period of time and get past the high pricing, not using the chillers, get past the high pricing and get to a point of low pricing where then they can fill up the tank. So that's really important information for them to know that 17 hours there. Um,
Okay, and this actually impacted the way they ran it, right?
yeah,
And that's what I wanted to show you the next slide here.
yeah. This is
So I'm showing
amazing.
the next
Yeah,
slide.
this is like the classic put the data in front of the users and they change their behavior. We also met with them and told them what we wanted them to do. So it wasn't just that um, we informed them about the data, but so let's see. The period in the top graph prior to training is in November of 2019, and then the period in the bottom graph is in December of 2019. And so one is before we talked to them and one is after, and you can see that really for historical reasons, the orange line and the green line are peaking at similar times. So what that basically means is that we're using our electric chillers at the same time when the price is the highest.
Right. So
Um,
these right here.
yeah,
Yeah.
and this was happening, I would say, largely due to the fact that there were historical reasons for running this way that may have been price driven, but the California grid pricing has changed significantly so that daytime electricity is much less expensive because of the amount of solar on the grid. And so we hadn't really changed our operations to account for that. And then furthermore, as I mentioned before, we thought it didn't matter because we thought our electricity pricing was flat. So you see that within a month, they've basically really impressively changed. There's not any optimization algorithm or anything. This is just literally them looking at this screen and us telling them, "Hey, we want you to run the chillers when the power is cheap." And they,
That's very
yeah,
cool, and that's exactly what they're doing. So
yeah,
they're avoiding the spikes in the price
yeah,
and
and
where they can.
they're doing it
That's
quite
very
well. I
cool.
mean, you can see even it looks to me like the between the the second spike to the right and the third spike to the right, it looks like they've actually maybe gone for 2 days. I need to think about this. Oh, maybe not. I
Mhm.
think they've at times been able to actually go for 2 days without running the chillers when needed. The power of putting data in front of operators.
Oh, that's very cool. Okay. Well, hey, what kind of advice would you have to somebody who's trying to make better use of their real-time data in facilities?
Um,
Anybody who's like at a point where you were when you first came in.
yeah.
Maybe they have a system that brings the data. Maybe they don't. What would you suggest?
Yeah, I mean, I would say that just prioritize and take things a little bit at a time. I think that it's overwhelming. There's this feeling with data that you're always behind, that you're always a little behind where you want to be, and part of that I think is just due to the fact that there's a lot that can kind of drift, but also just the fact that as technology improves. Uh, there's more to do to sort of stay up to speed, and it's possible to kind of do bits and pieces and not really ever kind of get any sort of comprehensive program. So I would say like prioritize and do things a little bit at a time, and then also try to do things in kind of a way that changes processes, so that at least if you've done something, then it'll stick, and you have processes that will allow it to stick. And then I think another piece of advice is try to get management buy-in into the value of data, and so that management understands it and supports both in terms of time utilization of existing staff and potentially hiring of new staff, that kind of endeavor. I was hired, I'm kind of in a different role now, but I was really hired in a role to work on data. And that was something that management thought was valuable, because we think that our part of our mission in utilities is to not just keep the power on, but also to provide data to the campus and to the public. So if you have that
Mhm.
buy-in, and I think we have control. In my case, I was hired into a team that already had that kind of belief, but I think we do have some control to maintain that belief and show the value of data. So,
Very
yeah.
cool. Very cool. Okay. Well, we don't have any questions from the audience, and if there's anything that you wanted to talk about that we didn't talk about, please let me know. What I wanted to do though, real quick, is just a quick lightning round of different questions for you.
Sure.
So right off the top of your head, okay?
Mm-hmm. Here we
You're
go.
okay with that?
Yeah.
Great, okay. So, first question is, were there any surprises when you started working within the university environment in like the power profile of daily use that you see? You know, because it stunned me when I first started realized that everybody uses electricity when they go home and turn on their ovens, right? But I'm guessing it's not like that on campus.
Yeah. The surprise for campus is how large our base load is. Um, we have a 40 megawatt peak and a 20 megawatt base load. And it's just it's amazing just how much power we use when no one is here. And most of that is just because of the fact that it's not true that no one is here. In particular,
Okay.
we have animals here, and other we have a lot of animals here. But there's other researchers and critical stuff that's going on that uses essentially when nobody's here, we're using about half of what we are using when everybody's here.
Okay.
Yeah.
How about the days of the week? Any days of the week that stand out as anomalies in university life?
I mean, Saturday and Sunday are lower use in terms of
Lower use.
electricity.
Okay.
Yeah,
Yeah, it would make sense.
yeah.
Okay. Okay.
Sunday, probably Sunday. I think everybody's a little the most lazy on Sunday.
Okay. Okay. So, do you currently have a piece of broken gear or fried motherboard or whatever that you keep on your desk as a memento?
Um, I don't have anything. Oh, I can share a few things. I have some fertilizer produced by our renewable energy anaerobic biodigester. So the effluent, we're trying to turn the effluent of that into fertilizer, and I have a bottle of it on my desk. I've not yet had the boldness to pour it onto my roses, but hopefully I'll get there
Okay.
sometime.
Okay. So, what kind of thing keeps you up at night worrying about facilities in a university?
Yeah, I'm blessed that right now I'm in a role where I don't have a lot of 24/7 support. I imagine I will probably eventually aspire to such a role. So, the thing that comes, if there's anything that keeps me up, it's probably the Pi system, and like if it breaks, that honestly has been one of the things that's kept me up and gotten me up early when things go, if there's a network switch outage. So that, it's my baby in that sense that I'm like, if it's broken, I want to fix it within 30 minutes. And then the other thing is just, as you become a supervisor, um, the needs of my team and the responsibilities of doing a good job for the campus and for all our stakeholders really can weigh on me. And yeah.
What's the first computer you ever used?
Oh man, probably an Apple II.
Okay.
Yeah.
Okay. Is that like in school or
No, like at my
um,
friend's house, we had like really, really cool games we played on the Apple II,
very cool?
Space
Very cool.
Quarks,
Okay.
Space Quarks.
Okay. So at your location, what's the best view, and what are you looking at when you're looking at the best view?
Oh man, there's a lot of good views here. I'd say my favorite view is we have as I mentioned, we have a large campus, 5,000 acres. We have some really beautiful agricultural land with vineyards on it that kind of faces out toward the hills. And there's like all kind of a row of olive trees with vineyards in the background and then hills behind that. For me,
Very
that's
cool.
it. Yeah.
Okay. And just describe a day in your life. What kind of stuff do you do?
Yeah. I'm doing a good amount of email and helping my team with questions, and then um, working with other folks, going to quite a few meetings, maybe sometimes a few more than I'd like, and then usually I have a few projects that I'm still the lead on, largely related to our purchased utilities budget that I'm trying to push forward in my spare time.
Okay. Great. Great. Well, David, thank you so much. Thanks for. Let me just double check and see if we've gotten any questions that came in. And let's see. Um, let's see. Just a comment. This comment is to prioritize, focus on lasting process change, ensure management buy-in. I think someone's taking notes. That's exactly what you said, right?
Yeah,
But that's words to the wise, right?
yeah,
Yeah. It's funny. Larry Schutzberg said very much the same thing. He said, we interviewed him last week,
yeah,
and he said, yeah, you need to get buy-in. he says grassroots, maybe, but you need somebody that can push it and empower you to make change.
It's true,
So
you know, as leadership kind of changes, you really sometimes when a change happens, you really see the impact of having buy-in and then moving to not having buy-in or vice versa. And you didn't realize, you know, oh, you know, I was able to do this because I had because the person, one or two people above me believed in this. And then if they don't, it's like you have to decide, well, should I keep going or just let it go because they don't care, you know? So, but
yes,
so then there's that decision point of whether you think it's at some point you have to say this is valuable regardless. But yeah,
yeah, right. Well, thank you so much again for sharing what you know about working with real-time data with us. Thanks again.
thank you. Thank you so much for having me.
Right. And thank you all for joining us again. It's Nick Durazio. Bye bye.